Hello everyone, welcome to the Falcon Mathematics channel. Today I will show you one technique. Then by using that technique you will be able to solve each exact differential equations. And this technique has two steps. Your first step is you need to be sure that your differential equation is exact differential equation. And the second step is if you have exact differential equations, you know two things and I will explain what they are. Now, the first step. How can we show that one differential equation is exact differential equation or not? First of all, you need to write, if it is not written like this, you need to write your differential equation on this form. M dx plus n dy equals 0. Right hand side must be 0 and you have dx with any constants, n doesn't matter, sorry, coefficients m doesn't matter, and n. N can be any function, m can be any function, but if you want to show that one differential equation is exact differential equation, you have this equality. My must be equals nx. Then you say that I have exact differential equation. So in here, consider this differential equation here. What do we have? We said that m is the coefficient of dx. So here the coefficient of dx is y squared plus cosine x. So we say that this is m. And n dy. So n is the coefficient of dy. So we call that this is n. Then we know m, we know n. Then we know this equality. If we have this equality, we say that our differential equation is exact differential equation. So let's check. We said that m is y squared plus cosine x because it is the coefficient of dx. Then can you tell me what is my? You know that my is the derivative of m with respect to y. So here, take derivative of m with respect to y. Y squared give us 2y. But cosine x, we don't have any y here. So the derivative of cosine x with respect to y will be 0. So my is 2y. And consider n. As we said before, n is the coefficient of dy. For this question, n is 2xy plus sine y. 2xy plus sine y. Then we need to find nx. As you know, nx is the derivative of n with respect to x. Here, 2xy, the derivative of x is 1, and the constant part is 2y. 1 times 2y, we get 2y. And similarly, we have sine y. We don't have any x in here, so the derivative will be 0. Then what do we have? My is 2y, and x is 2y. They are equal, right? Then we say that our differential equation is exact differential equation. So first step is over. Then the next step, why it was important to say it is exact differential equation? Because if it is exact differential equation, if you have exact differential equation, you know that I have a solution and my solution is fxy equals 0. This is our solution. Actually, we don't know what exactly f is, but if it is exact differential equation, as I said before, you know two things. One of them, the derivative of f with respect to x, which can be represented fx, is exactly m. And the second one, the derivative of f with respect to y, which can be represented fy, is exactly n. So if you have exact differential equation, you know that fx is m and fy is n. Now we are going to use these two equalities to find our solution of this differential equation. And do not forget that the solution is f, not fx, not fy, it is f. Now let's call that this is our first equation and this is our second equation. Now consider the equation 1. what do we have? We have that the derivative of f with respect to x is m, because it is exact. So we have this equality. How can we find f? F is our solution. How can we find it? Here, if you take integral for both sides, imagine that we have derivative of f with respect to x. If you take integral with respect to x, then derivative and integration will be cancelled. Then we get only f, right? Consider. You have derivative and integration, then you will get only f. But we need to take integral for both sides. So here will be integration of m with respect to x. Then what was m? We said that m is y square plus cosine x, right? So y square plus cosine x. So what is it? What is f? We are going to find f. We are going to find the solution f. Integration of y square depends on x. It will be y square x. And the integration of cosine will be sine x. And don't we have plus c? We have more than c. This part is important. We don't have only c. We have cy. Why it is so important? I want to explain it clearly from here. Okay, here. Think about simple. Can you tell me the derivative of x squared? What is it? It is 2x, right? And can you tell me the derivative of x squared plus 1? What is it? It is 2x, because derivative of 1 is 0, right? And can you tell me derivative of x squared plus 5? It is 2x again, right? Now, doesn't matter what do you have as a constant in here. In general, we represent all constants as c. The derivative give us 2x. That is why we call that integration of 2x is x squared plus c. But if you are talking about two variable functions, it doesn't matter. If you have x squared plus y squared, if you take derivative of x squared plus y squared with respect to x, again you have 2x, because y squared for x, for taking derivative with respect to x, is 0 again. So if it is y cube or sine y, doesn't matter, it will give us 0 for taking derivative with respect to x. So we can represent any function depends on y as cy. That is why we don't have only c constant values. We may have y functions as well. Then we call that it is cy. Sometimes they represent hy or doesn't matter. They can represent gy. Depends on you. The important thing is we have this equality. We said that fxy was the solution of this differential equation, but we have fxy, it is y squared x plus sine x plus cy. Now, here, this is our problem. We don't know what is cy. We know that there is a function, depends on y, but we don't know what is it. So how can we find it? Now, in this equality, we used the first equation. Now we are going to use the second equation. And you can see that second equation depends on fy. What is it? Derivative of f with respect to y, right? So if in this equality, if you take derivative for both sides with respect to y, on left hand side, what do we have? Fy. On right hand side, what do we have? Derivative of y square give us 2yx. Derivative of sine x with respect to y, it is 0. And you don't even know what is cy, so you can say that it is c prime y, because we don't know what is it, right? Why I took derivative of this equality with respect to y? Because in here the second equation says that fy is n. So here is n. Then right hand side 2yx, can I write 2xy? And also in my differential equation I know that n is 2xy, n is here 2xy plus sine y, right? Right hand side same. Then both sides has 2xy and 2xy, they will be cancelled, right? Then we get sine y equals c prime y. We are looking for f, and f has cy, not c prime y. So we need to take integral for both sides with respect to y. So if you take integration of sine y is minus cosine y and plus c, and here again integration and derivative will be cancelled, then we have only cy. Now we found cy function as well. Now we said that our differential equation is exact differential equation, and that was the solution, which is fxy, which is 0, right? Now consider here fxy is what? Fxy is y square x plus sine x plus cy, but I know that cy is minus cosine y plus c equals 0. I just replaced the definition of fxy in here, equals 0. So this is our solution of the differential equation. This is the technique. Let me explain it again. You have differential equation. You need to show that it is exact differential equation. How can we prove that it is exact differential equation? We need to check this equality. If my equals nx, then you say that it is exact. Why it is important to say that it is exact? Because if it is exact, you have a solution. You don't know what is it, but you know the derivatives. Then you can solve your differential equation by using these two equalities. The derivative of f with respect to x is m. The derivative of f with respect to y is n. So you can choose one of them. It is fx. How can we find f? We should take integral. Depends on x. Then we get f. But if you take integration with respect to x, you have y functions. You don't know your y functions. Then here you can use the second one, which you didn't use before. So here the second one has fy. So here we have f. That means we need to take derivative with respect to y. Then we get fy. But you have this one. This is 0. So c prime y. Why? Because fy is n. And you know the definition of n. Then you will get c prime y. So you can find cy. Then when you replace cy in here, you can find fxy, which is your solution of the differential equation. Then you can finish it. Then for more techniques about differential equations, you can subscribe my channel. Thank you.